So we will see the Fourier transform, Fourier transform, Fourier transform. Actually, Fourier transform is another Fourier analysis tool, and we use this for a periodic signal. Okay, that means non-periodic signal. Okay, non-periodic signal. Okay, for the periodic signal, we are normally applying Fourier series. Okay, but to analyze the non-periodic or aperiodic signals, we need to use Fourier transform. Okay, so in the same manner, there are identity for a periodic signal. Okay, for the discrete time signal, actually we are focusing on discrete time signal here. Okay, and in the same manner, yeah, this one. Okay, so this is the equations we use to analyze of discrete time aperiodic signal. Okay, this is referred as Fourier transform. So you can see that there is actually, so you can see that if you have a time domain signal xn, if you have a time domain signal xn, and if you apply Fourier transform, this time domain signal will be converted into frequency domain. Okay, so this n is the sample number. This is the sample number, and sample number is related with time. You know that. Okay, the time sample number is directly related with time. So we have seen this. Okay, so this is actually time value. N is a time domain value. Okay, so xn is a time domain signal. Okay, x is a function of n. N is a time related parameter. Okay, so it is a time domain signal. This xn is a time domain signal, and you apply Fourier transform, it will become a frequency domain. So it will become a function of frequency omega. Okay, omega is the angular frequency. You know that 25f. Omega is equal to 25f. Okay, so it will become angular frequency, function of angular frequency. Okay, and we represent that one using a capital X. Okay, capital X omega. So this will be the frequency domain signal. Now your independent variable is frequency. Okay, and if you apply inverse Fourier transform, okay, inverse Fourier transform, this x omega, it is a frequency domain signal, and it will become a time domain signal. Okay, for the phase wave. Okay. Okay. So these are the identity for the inverse Fourier transform and the Fourier transform. Okay. So you can see that this is a time domain signal, and it should be multiplied by these e terms. Then you need to get the summation from minus infinity to plus infinity. Okay. And if you want to find the discrete inverse Fourier transform, you need to evaluate this integration. Why here you need to do integration? Can anyone tell why we need to do integration? For a discrete time signal, we are normally getting summation. No, I have explained why we get summation, because there are discrete time, discrete values, so we can add them as a simple summation. But for the continuous time, we can't do that. We need to do the integration. So here the integration is there. Why is that? Can anyone tell? Why here integration? Why we have integration here? If it is an integration, definitely there. What is that? Is it a discrete time or continuous time variable? If we need to do an integration, is that integration deal with discrete time variable or continuous time variable? Tell me. If the integration is there, what is the variable type? Is it discrete or uh, continuous? Discrete variable or continuous variable? Integration එකක් කරනවා නම් ඒක discrete variable එකක්ද continuous variable එකක්ද? Please tell me. Yes, continuous variable. Okay, it is a continuous variable. So you can see that this omega, actually this omega is not a discrete variable. Okay, although this n is a discrete variable, once we transform it to omega, we can't say that this omega is also discrete variable. There is no such condition. Okay, so this omega can be a continuous variable. Okay, so there is an integration for that. Okay, so actually that is a problem. Okay, that is a problem when we deal with digital system. Okay, so there is a solution. Okay, there is a solution. We will see it later. Okay, now we will focus in on this one. Okay, so this will be the identity. Okay, this will be the identity. Okay, so if I first write the identity for Fourier transform. Okay, so if you are given any signal xn, if you want to convert this to frequency domain x omega, what you need to do? You need to get the sum, this n, all this n value, this n minus to plus infinity means you need to consider all the n value. But for the Fourier series, we are not considering all the n value. No, we considering the n value from 0 to n naught minus 1. You can see that. Okay. So actually, we consider only one sequence. Okay. This sequence is repeating. Okay. So this sequence only we get the we are focusing on this sequence only. Okay, not the repeating value. Okay, but here this one is not repeating, so you need to get all the values. Okay, because this is a periodic signal, not a periodic signal. Okay, so you need to consider all the values, but here only one repeating sequence is enough. Okay, so that is why this n from minus infinity to plus infinity xn, and it will be multiplied by j in omega. Okay, so once you apply n here, so you can see that your answer will be in omega. Okay, so this is the Fourier transform. Okay, Fourier transform. And if I let's do a simple question. Okay, so if I ask you to find the Fourier transform of this signal xn plus xn equal, let's say that delta uh, delta minus 2 plus delta xn equal to a delta n minus 2 plus this is equal to 2 delta n minus 1 plus delta n plus delta n minus 3. This will be plus. We will get this plus. Okay. So if I ask to find the Fourier series of this sequence, this signal, how you find? Okay. So I will do this. Okay. First, you need to draw this signal. Okay. So if I draw this signal, so you know that delta n is delta n is like this. Okay, this is delta n. Okay, so it will be 1. Okay, then delta n minus 3 means, okay, delta n minus 3 means this one, this is 0, 1, 2, 3. This is shifting up to 3. Okay, so here you will have, so this is 1. Okay, this is 1, and here you will have again 1 n minus 3. Okay, and here delta n plus 1. N plus 1 means it is shifting to this side. Okay, so this will be 1 and it is shifting to this side, and it is 3. No, this is 3, so this will be 3. Okay, and n plus 2. N plus 2 means again this one shifting to up to 2, so this will be 2. So and it will also 2. Okay, so this is your sequence. This is your sequence. Okay, this is your sequence. Okay, this is sequence. Okay, so xn, if I write xn, okay, this is the xn, okay, with respect to n. Okay, so I have 0, 1, 2, 3, 1, 2. Okay, and at 2 I have 2, at 1 I have 3, at 0 I have 1, at 3 I have 1. 1. Okay, so this is my signal. This is the given signal. Now I need to find the Fourier transform of this xn. That means I need to show this. We need to convert this n into omega. Okay, I need to convert this into omega. Okay, I need to convert this to omega. Okay, so for that one I need to get the Fourier transform of this sequence. Okay, so how to get the Fourier transform? X omega is equal to n from minus infinity to plus infinity xn e to the power minus j omega n. No, this is the Fourier series identity. N from minus infinity to plus infinity xn e to the power minus j omega n. Okay. Okay. So okay. Now I need to expand this. So this one is very easy. Okay. So I will expand this. Okay. So now my n is from 2 to 3. No, from minus, this is minus. Okay, minus 2 to plus 3. Okay, so n from minus 2 to plus 3. Okay, so I need to get all the value. Okay, that is what it says, minus infinity to plus infinity. So I need to consider all the terms. Okay, minus 2 to plus 2 xn e to the power minus j omega n. Okay, so very easily if I expand this, plus x minus 2 e to the power minus j omega n is minus 2 again, plus x minus 1 e to the power minus j omega minus 1 plus x0 e to the power minus j omega 0 plus. Okay, and you can see that 1, 2 are 0. Okay, so this will be 0, 1 and 2 will be 0, and again 3, x3 will be 1 e to the power minus j omega 3 in this 3. Okay, so now you have to substitute the value here. Okay, so x omega will be x minus 1 is 2. No, 2 e to the power minus minus, it will be plus. Okay, so it will be 2j omega plus x minus 1 is 3 e to the power minus 1 minus 1, it will be plus j omega plus x naught is 1 e to the power j omega 0. No, so this also will be 1, so it will be 1 plus x3 is again 1 e to the power minus 3 j omega. Okay, so this is the Fourier series representation of this sequence. Okay, so very easily you can find that one. Okay, uh, so so do some questions. Okay, do some questions. Okay, so there are some examples maybe. Oh, ah, okay. So you can see that some examples are there. Okay. So try to do these examples. Okay. It is maybe related with Fourier series. Okay. These are Fourier series. Okay. So these are the example for Fourier transform. Okay. So try to do this example. This example 2.5. So all are solved one. So maybe you can do this by yourself. These are not much difficult. Okay, you need to use that summation. Okay, so try to do this. Uh, Try to do these examples. Okay, so maybe if you have this kind of one omega naught n. Okay, maybe it is easy to use the Euler formula here. Okay, so cos omega naught n can be written as e to the power j omega naught n value. So actually it will be e to the power j omega naught n plus e to the power minus j omega naught n. You can write this cos omega naught n as e to the power j omega naught n plus e to the power minus j omega naught n. Uh, this un represent that, so you know the un means it is in plus side. Un is from plus side, 0 to infinity. So this un just implies that the signal is in plus side, not the minus side, minus infinity. This is starting from 0 to infinity. Okay, so so try to do this one using the Euler formula. It will be not much difficult. Okay, try to do this. Okay, so here you no need to worry about the region of convergence. Okay, region of convergence. Okay, but in Z transform, you need to worry about the region of convergence. Okay. Uh, uh, Actually, for a Fourier series as well as Fourier transform, there are some properties. Okay, properties. So we didn't see the properties for Fourier series. Okay, but there are some properties. Okay, actually that property will make easy to solve some problem. Okay, so using these properties we can easily solve some problems. Okay, so for a Fourier transform we will see some properties. Okay, we will see some important properties. Okay, actually there are some properties. Uh, these are the property table. Okay, so this is the time reversal property. We will see that one later. Okay, and I can't remember these properties, and there is a convolution property also. Okay, so we will see some 3 or 4 properties in next session. Okay, in next session we will see some properties. Then we can conclude this Fourier transform also. Okay, after that we will start discrete Fourier transform. Okay. So try to do those questions, example 2.5 questions by yourself. If you have any problem, just tell me. Okay. Uh, do you have any problem? If you have any problem, you can ask. Okay. And your mid exam will be maybe, I don't know, because I doesn't have. I will send you the reference book. Okay. Just give me a moment. I will send you. මම දන්නේ මේ මට LMS එකට දුන්න ඇක්සස් මේ පාර. ඒ මොකක් හරි අනේ මම දන්නයි කියලා. කොහොම ඉන්න මේක මාක් කරන කල්ල.